In this lesson, we are going to be putting together 3 of the last few topics that we've been talking about in Chapter 9, and this is all related to quadratics. So we've talked about 3 methods this unit so far and just this year. Method 1 is solving with tracks, train tracks. Method 2 is solving with factoring, and method 3 is solving using the quadratic formula. So I'm going to give you a few hints or kind of reminders about each of these methods, and then we'll do some examples. So method 1, solving with tracks, the time that you would do that is when there's only an x squared with no x term, or if there's only an x term, no x squared. So those are the very basic ones that we did at the beginning of the year, like 2x plus 5 equals 12. Very basic. You subtract 5 and divide by 2. Something that has an x squared but no x might look like 3 times 2x plus 5 squared equals 100. We did those a couple days ago, and there's some examples of those on the bottom that we'll do in a minute. Method number 2, solving with factoring. That's when your equation looks like this: ax squared plus bx plus c equals 0. That's in standard form. And this is something that you can factor quickly, where you get the 2 parentheses for your answers. Okay? After you get those 2 parentheses for your answers, you actually have to take it a step further and set each of these equal to 0. So let's say this is x plus 2, x minus 4. We would want to make those each equal to 0 and then solve for x. So what number plus 2 is 0? So that would be negative 2. And then what number minus 4 is 0? That would be positive 4. So these would actually be your 2 solutions after you factor. So negative 2 and positive 4. The other day when we talked about factoring, we have not talked about solving it at that point. So after you do the parentheses, then you would want to solve it and set them each equal to 0. Method 3, we just talked about last class, excuse me. So again, this in standard form, so x squared plus bx plus c equals 0. And then you would use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so let's go ahead and do some examples. For a, first of all, we need to make this equal to 0. And for e, we need to make that equal to 0. Those were typos on my part. So make those both equal to 0. So for a, I'm going to kind of go through each method and see which one fits. So I have x squared and an x. That means I cannot use method 1. And I do see that it's in standard form. So I'm going to try to factor it because that's usually quicker than using the quadratic. So remember, with factoring, we want to see what adds up to make 7, but multiplies to make 10. So I'm going to think of my factors of 10, 1 and 10, and 2 and 5. Well, 2 and 5 are the ones that add up to make 7. So I'm going to say x plus 2, x plus 5. But now I need to go ahead and solve that and actually figure out what x is. So I'm going to say x plus 2 equals 0 and x plus 5 equals 0. Well, in this one, x would be negative 2. And in this one, x would be negative 5. So my answers are x equals negative 2 and x equals 5. All right, next one. Again, I'm going to run through my list and see which method makes the most sense. So I see an x squared and an x. That means I cannot use method 1. I see that I could put it in standard form, so I'm going to try that and see which method I might use next. So to put this in standard form, I would want to add 3 to both sides. So then I would have 6x squared minus 13x plus 6 equals 0. Because of this 6 in the front, that's going to be kind of challenging to factor. So I'm going to use the quadratic for this one. So in this one, my A is 6, my B is negative 13, and my C is 6 as well. So I'm going to say, I'm going to say 13 plus or minus the square root of negative 13 squared minus 4 times 6 times 6, all over 2 times 6. So negative 13 squared is 169, and then negative 4 times 6 is negative 144. So next I would have 13 plus or minus 169 minus 144 all over 12. So 169 minus 144 is 25. The square root of 25 is 5. So now I have 13 plus 25 over 2, and I have 13 plus 5 over 2, and 13 minus 5 over 2. So 13 plus 5 is 18, divided by 9, or divided by 2 is 9, so x could be 9. That would be one of my answers. And then 13 minus 5 is 8. 8 divided by 2 is 4, so x could also be 4. All right, next one. Sorry, this is kind of blurry. You guys, I can't get my document camera to be any more clear, so I apologize for that. All right, next one. I see an x with parentheses and something squared, but there's not also a separate x term. So we're going to do train tracks for this one. This is the kind that we talked about the other day. So I'm going to add 14 first. I'm doing like PEMDAS backwards. So 4x plus 3 squared. Then 86 plus 14 is 100. Then divide by 4. So that would be x plus 3 squared equals 25. Then the only way to get rid of this parentheses is to take the square root on both sides. So then I would have x plus 3 equals 5 or negative 5. Remember, you have 2 answers here, and that's the part people often forget. So now when I get rid of the 3, I'm going to minus 3 to all of these. So then I would have x equals 2 or negative 8. All right, letter D. I see x squared minus 50 equals negative 1. So this is another case where we can use method 1 because there's only an x squared, not an x term as well. So this is a pretty straightforward one. So we're going to add 50 first. So then I would get x squared equals 49, and then I can just take the square root of both sides. But remember, the square root has 2 answers, so this would be 7 or negative 7. All right, next one, x squared plus 5x minus 7. So because there's an x and an x squared, I cannot use train tracks. I need to either factor or do the quadratic. I'm going to try factoring first and see if I can do that quickly. So I have to figure out what adds up to 5, but multiplies to make negative 7. So my factors of negative 7 are 1 and 7, and one of them has to be negative. So either negative 1 and 7 or 1 and negative 7. Well, none of those add up to 5. They actually add up to 6 or negative 6. So I'm going to use the quadratic instead. So a equals 1, b equals 5, c equals negative 7. So I would say negative 5 plus or minus the square root of 5 squared minus 4 times 1 times negative 7 all over 2 times 1. So negative 5 plus or minus 5 squared is 25. Negative 4 times 1 times negative 7 is 28. So plus 28 all over 2. 25 plus 28 is 53. So now I have negative 5 plus or minus the square root of 53 all over 2. So I have to do both. The square root of 53 is not a perfect square. So when you're typing this into your calculator, don't just try to do it all at once. So I would say -5 plus the square root of 53 equals, and then divide that by 2, because it's going to be a weird decimal. So I got 1.4. See if you can see that a little bit better. Okay, so I'm sorry, 1.14. So that would be one of my answers, 1.14. And then the other one I would do, let's see if you can see it. Okay, so -5 minus the square root of 53 equals, and then divide that by 2 as well. So -6.14 would be my other answer. That was a good example of why the quadratic formula was a better option, because we got decimals for that, and you can't factor and get the decimal answer. All right, last one. I see an x squared and an x term. I see x on both sides. I can't use method 1, so I'm going to get all the x terms to one side first. So minus 3x, so that would give me x squared plus 2x minus 35 equals 0. I'm going to try factoring it, because it could go quickly, or I could decide to do quadratic as well. So I have to figure out what adds up to 2 but multiplies to make -35. So my factors of -35 would be 1 and 35, with one of them being negative, or 5 and 7, with one of them being negative. Well, if I want to add up to make +2, I would want the 5 to be negative, so it's 7 minus 5. And then 7 times -5 is -35. So these are my two that I'm going to put in the parentheses, x minus 5, x minus 7, or plus 7, sorry. But then I have to go ahead and solve these. So this is where I make them equal to 0. So x minus 5 equals 0, x plus 7 equals 0. So here x would be +5, and here x would be -7.